Okay, hello everybody. So, first question I had was to talk about this question from the 2019 multiple choice. Okay, now if we look at this, we can see that there's an electrical circuit drawn. And because we've got an electrical circuit drawn, we have to identify what components we have in that circuit before we can do anything. Now the main component in this circuit is this one here. This is what's known as a transistor. Okay, and it's designed to only switch on when certain voltages go through it. And so everything else that's going on at the other side of the circuit here is what's controlling whether that will turn on or not. Okay. Now, the two components we have on this side of the circuit are an LDR, okay, which is a light dependent resistor. And this one here, because it's got the arrow through it, is a variable resistor. Okay, both of these are really useful in setting up what's known as a potential divider, which basically means that the voltage here from the supply is split between the two resistors that are there. Okay, now initially, if we look at the question, it says that the room temperature is 20 degrees Celsius. Now, given that there's nothing in the circuit that will change because of the room temperature, that doesn't really have a huge effect on what we're doing here, so we can discount that. It says that initially the lamp is on, it is off, sorry. So it then asks the lamp will light when. So we have to consider what's going on here. So if we assume that the lamp is off, which means that the voltage on this LDR is less than the voltage required to switch on the transistor, then how will this voltage become high enough that it will turn on the transistor? Well, we have a mnemonic we use when we're dealing with light dependent resistors, which is LURD. Okay, and it stands for light up, resistance down. Okay, and that means basically that if the light incident on that LDR goes up, the resistance value of that LDR will go down. Now the voltage divider works so that if the voltage of the bottom component goes up, the transistor will turn on. Okay, and when you look at potential dividers, the resistor with the most voltage always has the most resistance. So if light going up reduces the resistance, then it will reduce the amount of voltage inside the LDR. So therefore, in order for this lamp to be turned on by this transistor, the voltage in the LDR must go up, which means its resistance has to go up. So that means if the light level in the room goes down, the resistance of the LDR will go up, which will switch on the transistor and switch on the lamp. So therefore, our answer is A. When the light level is decreased below a certain value, the resistance of the LDR will increase to the point where the voltage flowing through it then flows through the transistor and turns on the bulb. I hope that was helpful. Good luck.